Share screen. Here we go. You got this part right. You got the A is 5x and the B is 2. So you got A plus B, but then it's A squared minus AB plus B squared. You just didn't square the 5x. It should have been 25x squared. And then
Oh,
the A times the B is 5x times 2. That's 10x plus the 2 squared, which is 4.
uh,
All right, so you said the 5 on the next part,
yeah.
6d plus 5 squared.
Mhm.
All right, so this is like the classic. You have to write it out as binomial times a binomial. And then you have to FOIL. The answer has 3 terms. That's key. So it's the rainbow method, FOIL, whatever you like. That's 36d squared times 5 is 30d plus 30d plus 25. 36d squared plus 60d. You can typically combine the outer and the inner, plus 25.
God, I think I just got confused 'cause I thought that was you would take like off of and square it. So yeah, I think
Yeah,
that makes sense now.
you're not allowed to just square them. You have to show it as multiplication. Um, what else on this page do you want us to look at? Our next pages.
Um, Maybe number 7.
Number 7. It's kind of an extension of the previous problem. If you got 5 wrong, you would probably get 7 wrong because you have to know to expand as appropriate here. So like this is 4, 1 minus x times 1 minus x plus the middle one, there's nothing to do. So you can actually just write it out as is. The last one is 2x plus 1 times 2x plus 1. There are formulas to shortcut the squaring. That's up to you if you want to remember those or not. When you FOIL this one here, you get 1 minus x plus x squared. 1 minus 2x plus x squared. All times 4, though. That has to come down. So then you get 4 minus 8x plus 4x squared. And then you can bring all of this down. Minus 2x squared minus 3x plus 9. Is that okay so far? Clear so far?
Yeah.
All right, the last one is also a FOIL. That's 4x squared plus 2x plus 2x plus 1. You have this negative out in front, so you have to negate everything. Minus 4x squared. That becomes 4x minus 1. And from here, you would just combine like terms. So, for example, positive 4x squared minus 2x squared minus 4x squared becomes minus 2x squared. Minus 8x minus 3x minus 4x. That's minus 15x. And then plus 4 plus 9 minus 1 plus 12.
got it. So mainly the expanding part might have where
Yeah,
but
it's a lot of steps, but yeah, it's kind of like everything else. Once you've seen it once or twice, you're like, all right, I can definitely do it now. All right, what else would you like us to look at from this?
um so when you look down here at the second page, the first three things I got wrong, the first 10, 11, and 12, it
Mhm.
seems like that was just due to the y-intercept, some problem with that.
Okay, let's look at the y-intercept for 10, and then we'll see if we can find maybe that's the same issue in all of them. So the y-intercept is when x equals 0. So you're finding f of 0. You're putting 0 in for x. So it's -5, 0 plus 2, 0 minus 1 squared, 0 minus 3 squared. It's possible that the issue is with the missing of the squareds. So this becomes -5 times 2, minus 1 squared, minus 3 squared. So this is -1 squared is 1, -3 squared is 9. So you're multiplying these together. Looks like it's -90. So to me, it looks like you didn't square the numbers. So why don't you try number 11 and see if you can tell me the correct y-intercept for that now that you've seen this one.
All right, I got -60.
Yeah, I agree.
I think the only thing is that before I thought it would just be you taking, like for example, with x plus 4, you would take 4 or 4, 1, and -3 and multiply those three, and that would give you
I mean,
the
that's if it's to the power of 1 each time. And then you also have to
no,
multiply the 1
but then would you, if you were to square the number when you're taking it, like for example, if it's 4, you would take 4, then 1, which is squared would still be 1
right.
times
That's
-3, but then I think I forgot to multiply each of them by the
the
5,
leading,
and
yeah, the leading coefficient. Yeah.
yeah, that's what I forgot to do on all of them.
I know this doesn't help, but if we had this as the review, this thing in front of us, I mean, you could have nailed every question. It's just not knowing what the teacher planned to present to you is the challenge. But this looks a lot like the homework we were doing also.
Yeah, I think it was 4.5.
Yeah.
That was the most
So,
like this, where it had us go directly from poem, to graph you do these all these steps.
mhm.
Um, I did end up looking at what I got wrong 13, 14, 15 in class when she was showing it.
Okay.
And for almost all they are these for the 13, she wanted me to expand it into x plus 1, x minus 1 before going down.
Yes. Yeah.
And also I tried to simplify the radical down there, but I kind of messed up with the simplification. She just wanted us to leave it as plus or minus I square root of 6.
Right, because 6 doesn't reduce. The square root of 6 is 2 and 3. There's no pairs. That's why it can't be broken out. But the negative can come out.
Yeah. And then I think it's the same thing for number 14. It didn't expand the x squared minus 4 into x plus 2. X minus 2. So,
Yeah, if it says, thou shall factor, thou shall factor. That's there's a
yeah.
lot of business books and things like that too. It's like people want their Internet Explorer fixed. You fix their Internet Explorer.
Yeah. Then number 15, she wanted us to write all the factors in like one line and then go down instead of writing the answer like right there. So it didn't show all the factoring in one like that. So that was that. Uh,
Well,
um,
I mean, I see some improvement on this one. Like I don't see, entire questions crossed out. So I think there is there's some things to take away from this that are good. Um, I don't know. How do you feel about the test?
I think if I just paid a little more attention, like of course in like the graphing area where I could have like multiplied by the gradient coefficient, but I think that was slightly conceptual because before when I was practicing too, I kept on not multiplying it by the leading coefficient, or like I wasn't consistent with that, so maybe like a little bit more practice might have helped, but
I mean, I
that,
don't know how many points you lost in like 10, 11, and 12, but that if when you get the same thing wrong on 3 questions in a row, it's pretty, I mean, that's tough because you're getting penalized every time for making the same mistake in all of them. So yeah, that's just my sort of thought. You might be able to go and ask for some more points, but was there more to the test or is this it? Is there
this
like
was it.
okay, all right. Um, Very good. So what should we do now? Do you have some new stuff to work on? Do
Yeah.
you want some problems like these? Okay.
We just started 4.6, which is polynomial division.
Okay.
Um, Leave screenshot the question. So this is the one that's um, polynomial divisions dividing using long division.
Yep. All right. Well, yeah, we can start with this question here. Most students don't really like the long division, but that's what they start with in this course. One of the things is that you have to fill in missing terms. So it's really 5x to the fourth minus 2x cubed 7x squared plus 0x minus 39. You have to remember to include like you got to
Yeah,
get all the x terms, even
isn't
if
that
they
this?
aren't don't.
Isn't that the same in synthetic division? The other
Yes,
type of
exactly.
one in the
Yep,
house?
yep. And so this goes inside the house, and then outside the house is x squared plus 2x minus 4. So the setup's key. If you miss a term, your answer will be off. Your teacher will do that on a test or quiz. Is that okay?
Yeah.
All right, so our goal is to get to 5x to the fourth from x squared. So that is 5x squared. And notice I put that above the x squareds.
Wait, I do have a question. So
Yes.
wouldn't the negative 39 be, oh wait, never mind. I was thinking of, yeah, never mind. So you would have to put plus 0x,
You do have to
or,
include that, yeah.
all right.
I don't make the rules. It's just the way it
Uh,
goes. Helps
zero.
to follow conventions.
Wouldn't you divide, you divide like the 5x to the fourth by x to the second? So then,
That's right. You
but
take the leading thing. I say it differently. I say, what do you multiply x squared by to get 5x to the fourth? But it is 5x to the fourth divided by x squared. That gets you what goes here. And then you're going to multiply each of these by the
yeah,
5x squared. So it's
yeah, that's
5x to the fourth plus 10x cubed minus 20x squared.
And don't you flip the signs because you're subtracting it, so then wouldn't you?
Yeah, I write change the signs, and then that way you're adding now. You're now adding. When I learned it, I just subtracted, but as someone who teaches this now, I think it's better to say change the signs. You should always get 0 in the leading position, and you don't even have to write that. Minus 12x cubed plus 13x squared.
Let me bring everything else down
If you
here.
make one error in this, it propagates through the entire rest of the problem. So please be careful. Then you bring down the next term, even if it's 0x. And then to figure out what goes in the next position, it's the leading term divided by the x squared. Or the way I always rephrase it as, what do you multiply x squared by to get minus 12x cubed? It is minus 12x. It has to match it exactly. Is that clear so far?
Yeah,
Then you take that minus 12x times each of these, and you get minus 12x cubed minus 24x squared plus 48x. And then again, you change the signs. So positive, positive, negative, and then you add vertically. So 37x squared minus 48x. Is that okay?
um, let's- let's- but then wouldn't you drop the negative 39 down as well?
You do bring that down, yeah. Just making sure. And you should double check me here. It's easy, so easy to make mistakes on these sign errors and this and that.
Yeah, I think it makes sense.
All right. What do you multiply x squared by to get 37x squared? Or the way you were presented in class, you take this leading thing under the
So
under
wouldn't that
the
be just 37?
yeah, so
Because
plus 37. And you multiply everything by that. And this one didn't work out very nice. And then again, you change the signs. Is that okay? Kind of.
yeah.
All right. Negative, what is that? 122x plus 109.
So then wouldn't
Yeah,
that be the reminder or the remainder
yeah, that's
then?
the remainder. This is up here is called the quotient. This is the divisor. You write your answer as the quotient plus the remainder over the divisor, unless it just asks for the quotient.
In this case, it would be 5x squared minus 12x plus 37. 37 plus negative 22x plus 109 over x squared plus 2x plus minus 4.
Yep. It depends on how your teacher wants you to write it. There's also sometimes, this is very rare, but sometimes they have you take the divisor times the quotient plus the remainder.
I think what you did in class is like whatever the polynomial is at the bottom, just put that over the divisor, then
Divisor,
that would
yeah,
be the
yeah. And I think this thing under the root's called the dividend. Useless Jeopardy knowledge. If you ever go on there. Okay. Um, Questions, thoughts on that?
yeah, I think I got it.
Okay. What else do you have for us to look at?
Uh, this one is divide using the synthetic division. Number 4.
Okay. So just like the previous problem, you do have to include the x terms in descending order. The way I present this might be differently than the way that you'd see it in your seen a lot of variations. I put the number in the I call it a box over here on the left. You might see it differently, but then you write the coefficients, something like that. So the reason it's -3 is you set the factor equal to 0. That's the thing you'll mess up on a test if you're not paying attention. You put the wrong one in there. Not you, but just in general. Do you remember how to do the manipulation of the numbers now once it's in this format down here?
Yeah, I think I'll go
Okay,
where
so,
wait,
so go ahead.
yeah.
uh, Go ahead and
Yeah, I was
try
just
this
doing
and let
it.
me know.
Yeah, I was just doing it in the wrong square. That's why I didn't recognize the question, right? See, so -3 on the outside. So, all right, I got x squared minus 3x plus 5 plus
Like
negative
like
9
that.
over x plus 3.
Okay. So your remainder is -9.
Yeah.
I agree. That looks good to me. Yeah.
Um, right. Next one is in the oh, I think I forgot I screenshot the directions, but
What are the
here,
directions? Just to use the synthetic
it,
division
yeah, use
to,
synthetic division to evaluate the function for
yeah.
the indicated value of x.
Yeah, so this time you're just putting that X value in the box and then the coefficients, and you're just doing the
So you don't
same
take the
thing.
opposite of the x value?
No, no, you use the X value for that one because the factor that it goes with is X plus 4.
Oh, so then when you solve for x, you get -4. Got it.
Yeah.
Wait, so I do have a question. For the remainder, would you put it
Remainder. Yeah, remainder.
the remainder
Yes.
would you put it over
No, no,
-4 or
no. This
just on
this
its
time
own?
this time it's just that number. This is the answer. A of -4 is -27. It is the remainder.
Got it.
And it'll say on the
27.
test, like, use the polynomial remainder theorem. This means to do this.
Yeah, I think it talked about it in their class notes. The remainder. Got it. So then that reminder is the or remainder is the k equals -4. Got it.
Right.
I think I had a question. So, uh, so these two are also on the same sheet. I was confused on whether we would do them the way we do them to just define the zeros of the function to would it just be the regular.
Uh, so this is a fancy way of saying like you need a factor. And if they're already factored, you'd set them equal to 0. Like the one on the right's easier. You'd set the x terms equal to 0. On the left, you have to factor first or do something.
Got it. I was just confused about if we're doing the same thing for this as we did earlier on.
Um, well, yeah, I mean, this one ends up being x minus 3 times x minus 3.
Then you would set each of the x's to equal to 0. So then you
I don't think you have to use synthetic division there for this. I mean, well, you know what? I mean, you are in that, I guess. I mean, so you're maybe you're right. You have to like know that those are the zeros and then do this to find them. Do the synthetic division, which is really weird, but
Yeah,
that's what
that's why I was
that
confused because it's in this set of homework, but I'm not sure if she wants to use that or just do it the regular
I and the one on
way.
the right is more challenging because it's like you'd have to expand this. So you'd have to FOIL. You get the x squared minus 2x plus 6x minus 12 times the 3. And then you would get 3x squared plus 12x minus 36. And then you'd want to do synthetic division with each of them, each of the zeros that you already know. Or maybe ask your teacher, but I think it's like you already know the zeros, but you like use synthetic division to prove that it's going to work. Does that make sense or not?
Yeah,
And then the next one here is this becomes 3x minus 6 equals 0, so x equals 2.
okay, I was not okay. Basically, just expanded and then did the thing for. Wait, I was gonna ask. Wait, why did you do it with -6 instead of 2?
You have to use one of the zeros. Like you know one of the
Oh,
zeros is -6 and one
uh,
is +2. Doesn't matter which one you use, but you use one of them to reduce the degree of it. And then this one you can just solve, I mean, you can't see the thing is you can keep using synthetic division, which is weird. And maybe that's what your teacher wanted. Like you could do it on this next line here. You bring the 1 down and then you get 0 again. And then you could do the same thing for this one on the right. You could do it for 2. Bring the 3 down. 3 times 2 is 6. I don't know what your teacher wants, but that's probably my best attempt at trying to figure it out.
okay, so I think all she's expecting is the first step of it, but could be wrong. All right, yeah. Uh,
Anything else you want us to look at tonight?
um, real quick, this I give a little bit of a stretch, but um, so this is actually from the next lesson, but we kind of got like half of the lesson done today, but this is on the half that we did today. So this is one of the questions, and it says completely factor each of the following and state all the zeros of the function. State any multiplicities greater than 1. Remember that the degree should equal the number of zeros.
Yeah, so they're telling you there should be 5 zeros, and they're helping you out by giving you one of them. So you use synthetic division to reduce it. So we expect to get 0 down here at the
So
end.
then we did kind of do this in class, but once you get it to like to where all of them are x plus like number, x minus number, like when it's in its completely factored form, um, wouldn't you just say each of them equal to 0 and then just find x equals for all of them? And that would be the zeros?
Um, I'm
Or
sorry, I don't,
uh,
um,
basically like when you get the completely factored form right below there,
yeah,
um,
you get
yeah, then
x to the
wouldn't you,
fourth minus 13 x squared plus 36. You, you can, to me, you can factor this. This becomes x
yeah,
squared minus 9, x squared minus 4,
then you can
and then,
further factor it.
yeah. So this ends up being x plus 4, x minus 3, x plus 3, x minus 2, x plus 2.
Got it. And then for so now that you have all those completely factored in the completely factored form, yeah, then wouldn't you just set each of them equal to 0, then whatever you get.
Exactly. Exactly.
Yeah,
Yeah.
okay, got it.
This one's pretty nice. They usually don't work out that's nice, but that is a good thing.
Um,
Any
yeah,
other questions on this?
I think that's all for now. Yeah, I think that answers that question.
Excellent.
Figuring out.
Excellent. All right. So Tuesday, Thursday next week, we're all set as usual.